So hello guys, welcome back to the channel. Today we'll do a question on exact ODE. So first of all, I would like to tell the question, and that is under what conditions A, B, K, L is A in the equation ax plus by plus kx ly dy by dx equals exact. So basically we have to find the condition for which this differential equation equals to 0, this differential equation is exact, and also find the solution of the ODE. So first of all, I would like to tell what is an exact ODE. An exact ODE, like say we have an equation m dx plus n dy equals to 0. An exact ODE is of the form du equals to del u by del x dx plus del u by del y dy. So this is the form of the ODE, and here we have du equals to 0, and if this is the condition, then u of xy would be any constant c. We can find this by direct integration of du. And next we have that when we compare both of them, we get that m equals to del u by del x and n equals to del u by del y. Now for the next step, we consider that m and n are continuous with their partial derivatives also being continuous. Next we have that del m by del y equals to del square u del x del y, and del m by del x is equal to del square u del x del y. So we get this. So the condition is essential because if these partial derivatives are not continuous, then both of them won't be equal, and if m and n are not continuous, we can't find the partial derivatives of both of them. So this condition becomes really essential, that both of them are continuous, and with the partial derivatives being continuous, to find the condition for exact ODEs. So this is the basic condition for any ODE to be exact. Now we'll first try to bring out this ODE in this form. So that we can do by just multiplying with dx on both sides. So dx, kx ly, dx cancel out, and the remaining is dy, and 0 into dx is 0. So we get this. Now we can find that m equals to ax plus by, and we have n equals to kx plus ly for this equation. Now we'll find del m by del y, which comes out to be b, and del n by del x comes out to be k. So from the condition of exact ODE, that is del m by del n y equals to del n by del x, we get that b equals to k. So this is the condition for the ODE to be exact in our case, and if this condition holds true, then n equals to bx, or let's say n star equals to bx plus ly. So now we'll find the solution of the equation using exact ODE form, and by using exact ODE, I mean we'll use u equals to integration m dx plus k of y. K of y is some function of y. So let's say m dx. So m here was ax plus by dx plus ky. Now we have ax plus by. So integration of ax plus by would be, integration of ax would be with respect to ax squared by 2, and by would be bxy plus ky. So this is what we get. Ky is a function of y, means k is a function of y, and this is what we get. Now we'll differentiate del u by del this whole term with y with respect to y, and we know that del u by del y equals to n, which is equals to n star. So we can say bx plus ly equals to del u by del y. Now del u by del y equals to the derivative of this with respect to y. So this would be 0, this would be bx plus k of y dk by dy equals to bx plus ly. So bx cancels out and we have dk equals to ly dy. Now we'll integrate this and then we get that k of y equals to y square ly square by 2. Now we'll put it in the equation ax square by 2 in this equation and we'll get ax square this. So this is the solution of our equation, and now we'll verify the solution by putting this will be equal to some constant. Now we'll find del uy, we'll find du, which is del u by del x dx plus del u by del y dy, del u by del y dy. And after finding this with respect to x, we'll get ax plus by in the here, and here we'll get bx plus ly dy, which is equals to 0. Sorry for the miscommunication, misbalance, and which is equal to 0, and du equals to 0, and therefore u equals to some constant. So the solution of the differential equation is ax square by 2 plus bxy plus ly square by 2 equals to some constant. So this is the solution of the desired differential equations. I'll repeat the whole process. So first of all, what was an exact ODE? If we have an ODE of the form m dx plus n dy equals to 0, then du equals to du by del, and it can be represented in the form du equals to del u by del x dx plus del u by del y dy equals to 0. Then and we take that d equals to 0, then u of xy equals to c, and comparing both of them we get that m equals to del u by del x and n equals to del u by del f. M and n are continuous with the partial derivative being also continuous. Del m by del y comes out to be del 2y by del x del y, and del n by del x comes out to be del 2 the same, and both of them are equal. This is the condition for an ODE to be an exact. We check this condition for this equation and we get that b equals to k. That was the condition for the required ODE to be exact. Then we found the solution of the ODE by solving these, and in the end we verified that whether its du is coming out to be 0 or not, and therefore we get the solution of the required differential equation to be ax square by 2 plus bxy plus ly square by 2 equals to 0.